I will start in Portuguese and then I will make some announcement in English if you don't mind. Is that
Oh,
good?
no, not at all.
It's just that I guess, beleza. Let's just wait a little bit and then we're gonna start it. I don't see the page. Here we go. Ok. So, boa tarde, pessoal. Estamos aqui mais uma vez, reunidos para mais um tempo de debate, uma organização do Núcleo de Estudos de População e do Departamento de Demografia, da pós-graduação em Demografia da Unicamp. Estamos aqui reunidos para ver a apresentação de um trabalho de Afua Boateng. Right now, I will switch to English so that you can understand what I'm saying. So we have here today Afua Boateng. She is a PhD student at University of Vienna. She does research focus on fertility and education in low and middle income countries. Right now, she is a research assistant at Data Lab and research group at the Vienna Institute of Demography, VID, and where researching uses demographic and health surveys to explore education and its complexity relationship with fertility patterns. So Afua will present a work here about estimates of fertility using Bayesian models. So Afua, we are very happy to have you here. I'll leave the ground to you, so feel free to present and take the time you want. After you present, I will open questions to the audience that are watching us in YouTube. So the floor is yours.
Okay, thank you very much, Everton. Thank you once again for this opportunity to present our work. I will first start by sharing my slides. Okay. I will be presenting today on our paper titled A Bayesian Model for the Reconstruction of Education and Age-Specific Fertility Rates, an application to African and Latin American countries. The authors on this paper are myself, Delek Yildiz and Anne Goujon. They are both researchers at the Vienna Institute of Demography and at IASA. I will begin by first sharing some of our motivation, which is part of the state of the art, and our objective. I will spend more time on the model that we used and share some results from our model and share a few closing remarks about the topic. Many people who work with low and middle income countries, especially in African countries, usually use the demographic and health surveys because it is one of the most reliable and readily available data sources. However, the problem with the DHS is that there are missing data when you get estimates from there, such as inconsistencies in estimates even for the same years and countries. And also the DHS estimates do not always match UN values, although the UN World Population Prospect gets their information also from the DHS alongside other other demographic surveys and other registries. Example here about the situation with the DHS data quality is this plot that I think reflects the situation with the DHS. The problem with the DHS is that when it comes to getting retrospective data, that is birth histories, there's issues of misreporting and omissions. And it's not the fault of the DHS itself, but from participants. So my second point is seen here. We look at secondary education fertility rates for the 1990 to 1995 period. And we see 3 countries, Colombia, Ghana, and Ethiopia. For these fertility rates, we used the TFR2 package by Bruno Schumacher, and it's in Status. So if you want to know more about this, you can also look at that paper, and they go into more details about how you can get DHS consistent fertility rates. For here, the data quality groups are taken from the Schumacher's book as well on the data quality and consistency of DHS, also published in 2014. So if you want to know the categories and which country falls under which, you can also look at that. But for Colombia, which is classified as having good quality, you could see that for these different lines are different surveys that are taken, and the survey estimates are much closer to one another compared to Ghana, where the classification is moderate. And you could see even for the same age group, they have different starting points. And for Ethiopia, which is considered to have poor quality data, you could see the different surveys give almost different results. So the objective with this was to provide complete past education and age-specific fertility rates for Latin American and African countries using the DHS data set. And the reason for this was to provide estimates by education level for better projections, as well as to evaluate how previous education policies have affected female fertility rates. One situation with the DHS is that it doesn't conduct the surveys at regular intervals, which is 5 years, but it's not for all countries. So you will have, say, Angola, where you can't have the earliest surveys, but then you have like 2011 and 2015, but not later after that. And you have some countries where you have only one survey, and then there are others where you have more, but not at regular intervals. So our data that we used and the approach that we took was to combine and borrow strength from multiple data sources, which included the United Nations World Population Prospects age-specific fertility rates, the DHS itself, and total fertility rates by education level from Yildiz et al., which you could also find at here, looking at this paper, a flexible model to reconstruct education-specific fertility rates. However, it is limited to sub-Saharan African countries, and it doesn't have age-specific fertility rates. And we also use the Wittgenstein Center's population rates, which you can also find more details on at the Vic Data Explorer. And the goal is to also disaggregate the United Nations World Population Prospects age-specific fertility rates by level of education. And how do we go about this? We take a 2-step approach, and then the first step is applying a general linear model to the DHS data to fill in missing values. And these values will feed into our Bayesian model as initial values to help the model better have outcomes, or more or less to show the model what is supposed to look like, especially in relation to the curves. And we define our education-specific, age-specific fertility rate to be a function of education, the age group, the country itself, the period that we are looking at, and the interaction between these variables that we think better informs fertility rates. So for the education group, we use the ones provided by the DHS, which are in 4 categories. We have the no education group, primary education group, secondary education group, and higher education. And for our age groups, we have by 5-year age groups, And then the period is also by 5-year periods. In the step 2, this is where we apply the hierarchical Bayesian model, and it's a 3-level model where we find, age-specific fertility rates, education-specific age fertility rates, and education-specific total fertility rates. And we have data feeding into all these levels, and they are also relatively dependent on one another, except for this third model, which doesn't impact necessarily our education-specific, age-specific fertility rates. In our framework, as I mentioned earlier, we have 3 levels. So in here is the data that we already have, which is the UN ASFR, and how here is our precision, which is more like our assumption to help the model, our assumption on how well the model should deviate from the data. And this is also data-driven. And we have our weights from the Wittgenstein Center population data. And then this helps us to find our estimated ASFR, which we use it to also calculate TFRs. In our second level, which is more education specific, we get data from the GLM estimates, where we call it EASFR DHS, not because these are the estimates directly from the DHS, but because these are derived from the DHS. And we also have our ESTFRs, which we use also from the Yildiz et al. Paper, as well as the estimated or the derived ESTFRs from here. So with this data from Yildiz et al., which is ESTFR DHS UN, we take the UN consistent total fertility rates by level of education, and then we make it a benchmark to our estimates. And I will go more into detail about the mathematical model on the Bayesian part. So our ASFRs, which are age-specific fertility rates from the UN, serves as a benchmark to allow our estimates to know where to stop, more or less. So we are trying to match these and to disaggregate them as well. And we calculate these age-specific fertility rates by having the product sum of the education-specific fertility rates that I will talk about in level 2, and multiplying that by the weights from the Wittgenstein Center, and then we sum it over the education levels that we have. And here, this is our position, and this is based on our standard deviation from the UN ASFRs. In level 2, we calculate already the ESCSFRs. And for here, we say that our estimates, which becomes our final result, is supposed to follow a truncated normal distribution, like a half normal distribution, centering around the estimates we get from the GLM model, which is now our EASFR DHS. And this is by country, year, age group, and education level. And we also have a precision, which is specific to the country, year, age, and education level. In our code, we segregate the education levels. So then we have each education level having this sort of calculation and having a precision on its own. For our second level, we follow a gamma distribution, and we have 1 over sigma, where sigma is the standard deviation of no education group, not all of them, but this becomes like our initial values, and these values change. This is not the same throughout. It's not discriminate. It is, yes, it's not a specific points number, it changes. For level 3, for the TFRs, we do Latin American countries differently than we do African countries, because here we benchmark the African countries on the TFRs from the Yildiz et al. Paper. So for here, we have a different model than we have for African countries. And for the ESTFRs, our estimates here are always what we want out of the model, and is by country, year, and education group, because we can't have age specific in this situation. And it also follows a half normal distribution that is centered around our derived ESTFRs, and then also has a standard deviation on its own. And the derived ESTFR, which is the total fertility rates by level of education, is the sum of the education-specific fertility rate by 5, and we sum this over the age groups, just like you would calculate normal total fertility rates just by the different level of education. And here we calculate our standard deviation here as a precision, like 1 over sigma squared, and sigma squared here is our precision, follows a normal distribution. And H here is fixed at 50 to help the model move better. And we have eta, I suppose, which is also data-driven based on the GLM estimates. In our African countries, we do a little bit differently. Here, we are interested, of course, in the ESTFR, but we are benchmarking on the ESTFRs, UN ESTFR, which is from the Yildiz et al. Model. And this is supposed to help guide our TFRs that we are interested in about where it should go, more or less. And this for African countries is half normal and also truncated for only positive values ranging from 0 to 10. So that is where we set our maximum at. And then we have a standard deviation mu. And our ESTFR derived is also benchmarking more or less, again, on ESTFR estimates. So this is sort of like doubly calculated, but to make sure everything is following the right order as well. And our mu also follows a gamma distribution. And this is, sigma is also data-driven. And I will already show the results for Africa. These in blue are the different DHS surveys and the results we got with this data TFR2 model. And we're showing only here for the Democratic Republic of the Congo. And we compared with our Bayesian median, which becomes our output, what we calculated. And we could see for some countries is like for some years, and for higher education especially, we don't have enough data at all. But then we're able to estimate, the model is able to estimate these reddish, pinkish values. And we also calculated by sub-regions in Africa, East Africa, Central Africa, Northern Africa, Southern and Western Africa by level of education. And this is also like a weighted sum of the individual countries and over the regions in the period. And we could see in solid black is the overall ESFRs, and in the different colors are the levels of education. We see here in purple is level of education, higher education. So these are fertility rates by higher education. And we can see here that in almost all of the regions, for all of the periods, higher levels of education come the lowest. The women with higher education have the lowest fertility rates. And almost all of them as well, women with no education have on the higher end of the fertility schedule. But then you look at Southern Africa and you see that the fertility rates are arguably lower than the other countries, and you could see where fertility starts to decline. For the other regions, it's also declining, but not as strongly. For Northern Africa, for instance, you could see this sort of declining line, looking at the peak numbers. And for Western Africa, it is, but it's not going as steadily. It's more or less not declining as quickly as compared to, say, Northern Africa or Southern Africa. And now we look at the differences between the years that we started with and then where we ended. And we want to also look at how more or less fertility rates have changed, looking at these two time points. And we can see for most parts, there has been a reduction in many countries in Africa. But then for some levels of education, this decline is not the same, it's not happening. Even in Gambia, we could see there's an increase at some point. Also in Niger, for women with no education, you could see an increase. But for the others, they are all more or less at a declining level. But when you look at notoriously high fertility countries, there are increases in some levels of education, although not all. Then we look at Latin America, just to compare our estimates, our Bayesian estimates with the DHS survey estimates that we had previously. And we look at Guatemala, and we could see similar situation as with the DR Congo. We don't have the best of the data. And for some places like 1985, you could see a very huge spike, which doesn't really make sense. So we could see that for the most part, the model does a pretty decent job in filling the parts that are missing, the parts that are wobbly. And this is done inside the Bayesian model. And here we look also side by side for the different years, and also at the two different time points, the reduction, we would call it. And for all the Latin American countries that we looked at, they've all had a decline over the time that we started this exercise, which was in 1970 to 2020. We could see there's been a decline, but also Latin America started with even a lower fertility schedule than the African countries we looked at. So we were looking at two different, I would say, transition periods when we talk about fertility transition, where Latin America within this period had already started their transition, where Africa was yet to start. Well, at least most sub-Saharan African countries were yet to start this transition. So here we can already see that this has already happened. So fertility schedules are already much lower. So I'm already at the end of my talk. And a few closing remarks. We could see, as I said earlier, that the Bayesian estimates reflect the onset of demographic transition. And we could see that women's education influence fertility rates, especially for higher levels of education. We could see almost throughout all the countries that we looked at, that women with the highest level of education, higher education, had more or less the lowest fertility schedules at what we looked at. So thank you very much for your time and for this talk, for inviting me to share this work with you.
Oh, so thank you so much we appreciate the presentation. Was really, really interesting. A lot of formulas and a lot of, I guess there's also a lot of questions. I do have a couple of questions. I'm also checking here at the chat of YouTube. Until now, there's no questions. So I will start with my questions, which I hope can contribute to the debate and contribute to your work with DLEC. And So the first question that I have is concerning, actually there's a couple of questions concerning your inputs with
Okay.
the data that you use.
Yeah.
Have you done any search of analysis in terms of data quality?
Yes.
I mean, just like a level of undercounting of birds, of if you did some corrections of levels of what you get from the estimates. Have you done that, like applying some demographic methods? There are some a couple of methods that PF ratio of Bras, Arriaga. So there are a couple of methods that we usually use to correct the level of fertility when we do some analysis in terms of data from middle and low income countries. So what I was thinking, if you, before you start the estimates, so if you put it in your Bayesian model, you did some kind of correction. This is one thing. Another thing is this selection criteria that you use before you pull in the data. So you pull all data. I know that you have data from Latin America and African countries, and then you pull it. I was a little bit confused if you run the model separately for Latin America and Africa, or to do it all together. So this is another thing that I was thinking. But to start with, I have these questions, and then I'll let you answer. I wait for some questions from the audience. If they don't have, I still have a lot of questions to ask you. So go ahead, please.
Okay, well, thank you very much for these questions. The first one about the data quality. Sorry, I will just take a sip of water. So yes, with the data quality, so the TFR estimates already more or less deals with this to a degree, but not too much, because it provides, like, it's already sort of supposed to provide fertility rates similar to the ones that the DHS provides, that has accounted for like all that. Aside that, after we got the estimates from the TFR2 model, some results were not looking nice. They were like all the way up. That didn't make sense to even include in the initial model to begin with. So we had, and also in the model, in the TFR model, you get the standard errors as well. So with these standard errors, we cut off at some point and we remove these data that the standard errors are not like within the realm of logic. So we removed those as well before we included them into the model. But it was also a test of the model itself and how well it's sort of borrows strengths from other data sets, because we could see when we compared the age-specific fertility rates aside of the DHS with the UN values, and they were almost like a perfect match, more or less. So I would say it's a testimony to the model itself about how well it did. So we were more heavily reliant on the UN data sets when it came to the ASFRs more than anything else. And to the second question about the model pooling, for the first step, we did run everything together, but it's also country specific because we include the country as well in the formula. And then in the Bayesian, we separate the models because of the benchmarking situation. And we also run the model individually for each country. So in the code, we have for each country, year, age group. So it's more like a single round of running of each line.
Now, another question, I still wait for some questions for the audience, but like I said, I have a couple of, you did some check in terms, I will not say sensitive analysis, or kind of sensitive analysis, like compare your results, just take some points because you did a time series, so you go from
Yeah.
97 to 2020. I was thinking if you did some comparison with other data sources. Like
Yes.
you took like census for one of those countries, and then you look at what you get from the results that you estimate with your model in a certain point of time, compare with what you have from other sources like census from other countries or vital statistics from other countries that could provide some information about education. So you did some these kind of tests. This is one thing that I was thinking about it. And in terms of sensitive analysis, and this is what I was thinking, you feel part of the missing data using information from the countries that that has information, or the countries that have information about education according to fertility or for educational level of mother. I was guessing if that could bring some effects on the results, especially when for this missing data. If there is any sensitive analysis that you provide to say, okay, it's borrow information from existing countries, doesn't make any problem with the results that I get from the missing data. Yeah. So these two things I want to hear from you as well.
Okay, so with the first one about the comparing the data sets, I think this was a big issue, and this is something that we still necessarily haven't been able to do because we don't have exactly the level, the disaggregation by level of education that we have right now to compare. That was the reason or like the inspiration behind starting this in the first place, because you don't really have, so when it comes to African countries and Latin America, we don't have that yet. So we
Brazil, you do.
Yeah, now we do. Now we do. So please, if you have better models to check our estimates, please feel free to do that. But yes, this is one big inspiration while we did this. And because the VIC provides estimates, but only from 2020, which was also like a problem because they didn't go that far back. They didn't do the reconstruction. And so we thought it would be a very good exercise to do, which it turned out to be. And in terms of sensitivity analysis, we did a cross-validation, leave one out exercise at the end of our modeling, where we took anywhere from 5% to 15%, and this was at random. So we would leave out these information up to 15%, but for like the data set, and run it, and we saw that this didn't leave any dent in our estimates. It didn't affect the model's capability to make a prediction.
And there's another sensitive analysis that you could do. For instance, you can take census and you can estimate other kind of measure, not TFR, but you can estimate cohort fertility. If you have, I mean, just take another data set, or you can do also with the DHS as well. You can estimate also, because if you have full birth histories. I was curious to know if you did this check, like to see the evolution, because one of your graphs, you show the evolution of TFR by educational level of mother. I was thinking about if it's possible to compare this with the cohort fertility.
Oh, okay.
And also by educational level. I mean, okay. if the patterns that you get of TFR through time follows the same as cohort fertility. I was wondering if you did this kind of test, which I think it's going to be a very nice way of seeing if what you doing it's has some sense, you know.
Of course, we did not do the cohort situation, of course. But I don't want to sound biased, but we also checked our estimates with the Lex estimates in the TFRs. So we sort of like check, and that model is entirely completely different from this one as well. Although it also uses multiple data sets, it's a different approach than we took. And this is also like within the realms of acceptability, I would say, within the credible intervals. But we didn't go as far as to do the census and taking other data sets, because we felt, or at least at that point, I felt that we didn't have all the, except for the UN that we fully trusted, that was already a beginning problem where you couldn't find good enough data to check against everything to make sure all the parameters make sense. So for instance, if we expanded to the European countries and to the other countries that we do have good vital statistics, then we will feel more confident to check against them, and then we can correct should there be a need. But that is also like something we plan to do in the future, to expand to the global south. So
that's what that was my next question. If you want to expand the model, include other kind of countries. I mean,
yes,
which
we
would be nice.
plan to do that.
Yeah, because I think it would be nice as also a kind of check. Another thing is validation of your model. Did you compare your results with other Bayesian models that existed, like from Alkema, from Leontina? There are many others that they applied also to estimate demographic events when you have few exposure and few births of that. So did you did this kind of, because I'm trying here to be a devil's advocate, is just what do your model contribute to the existing literature?
Yes, thank you very much for that. Of course, we did other, I'll call it like a robustness check. We also developed other Bayesian models, although I would say very similar to the ones that we have right now, but we changed a few parameters here and there. And then we were able to compare and then choose the better fitting model. And with regards to the other Bayesian models out there, which is super great because they provide foundations to build on. The bigger situation, the bigger concern for us was that these models were not necessarily education specific. And as you mentioned, some model exposures, but they do not include, we took the fertility rates itself from the TFR2 model, and then we made a few adjustments here and there to accommodate, like to be able to use all these information that we already have. And we try to use more the more reliable data sources, I would say. And we also know that from, I think, 2020 already, maybe even earlier, that the UN has developed now a Bayesian estimation program. So the WPPs are Bayesian constructed. And I think Alkema is already on this team, as well as other bigger names in Bayesian are also working on this team. So we sort of like trust the expertise as well when it comes to the modeling aspect. But our essential contribution is to do this by level of education, which we felt is novel, or at least to our knowledge is the newer thing that we're adding, because we haven't seen that yet. And also providing this long time series, and also using that many data sources, I think, because we're using from everywhere.
Yeah, sure, that's great. I mean, it's a great exercise of demographic methods and statistics combined. One last question.
Yes.
Can you adapt this model? I know that's also many other models out there, but for forecasting. I know that there are some papers on cohort fertility forecasts, but I was thinking about period fertility forecasting. Of course, UN does this kind of stuff, but not by education yet. And I want to hear if it's possible to adapt the model, or are you guys working, planning to extend it for forecasting, which I think it's going to be an incredible contribution when you think about changing and mother educational composition through time, which your model captures. I want to hear if it's in the side of your research to do this kind of analysis.
Is not necessarily part of my plans right now, but I think it's adaptable for predictions. If you can adapt it, of course, definitely, it's very adaptable. And I think that's one thing that makes it easy to work with. So you can move it for the different time points, as long as you can have something to at least feed it into it. But I feel like projections is also a broader topic that involves a lot of estimations and a lot of scenarios that you have to come up with and adapt and change. And even though this model is good at capturing, but we already know what has happened in the past, so we can better inform this. But not to step on any toes as well. But at the moment, also the VIC is working on their projections, which is also by level of education. So that should be out soon. And then that is also taking in new information as well. And I'm very excited to see the estimates that come up like later when the projections are done as well.
Okay. So I don't have other questions, but I don't know if you want to say something else. I mean, we speed up and we did everything really short. I was expecting probably more people to ask some questions, but I'm sorry that I did have a lot of questions. I was really curious when I was reading your work. So I want to once more thank you for accepting to be present here to present your work. I also want to thank the audience who are watching us in YouTube. There will be a recording, and then I will share with you and share with everyone that missed it, and you can see it afterwards. So once more, thank you, Afua, for being here. It was really a pleasure from our side, and hope to see you again.
Thank you very much. Just one last thing before, if it's possible. So we have a website, populationafrica.org. You can check it out for more detailed data sets. If you want to download the data sets, there are plots there. If you want to download the plots for anything. And there are also some of the papers that I mentioned earlier, so links to that, so you can look at it if you want further information, and you can also always contact me if you have more questions.
Oh, that's
and
great.
Also thank you for this opportunity as well.
Thank you so much. So if there is no further questions, no further statements, see you everyone. Thank you so much. Have a nice evening, actually.
You too.
Bye.
Bye.
See you guys.